with me for a second. So, going to get into graphing. A little reminder that what does it mean to graph lines? What does an equation look like? Okay. So we have equations that are not changing. They're not going up. They're not going down. They're called constant. It means they stay at a constant pace. They don't go up. They don't go down. The only thing they start at a number like 8, and as they move along, they stay at 8. Y equals 8. So they don't go up. They don't go down. They stay at the same number. So this is just a simple equation. Y equals 8, or f of x equals 8. Okay. So first and foremost, a constant function has a slope of 0. The slope is the number that says how much is it changing. So if the graph or the line does not change, if it starts at -2, like right here on the y-axis, starts at -2, and way over here it's at -2, that means it didn't change. It was constant. Okay? And the simple equation is y equals -2. Y equals -2. And later on we're going to add in, well, why don't we start at -2, but we should change. We should go someplace so we can start changing the slope. So the slope says, how much does something change? How much is from where we start, how much does it change? So if we start at -2 and we end up over here at +2, how much does it change? How much does it change? And we have some negative changes. So if it starts at -2 and it goes down to -8, so it had a negative change, it went down. It can also have a positive change if it goes up. Positive change. So we can have positive change or negative change. We're always looking at this from left to right, so if it changes by going up, you know it's a positive slope. If it changes by going down, it's a negative slope. Now we use the word slope a lot in mathematics. However, it's not really used that often other places. It's usually speed, rate, velocity, change. So in any of your science classes, if you guys did graphing, you always use like velocity and speed instead of slope. But it means the same thing. It means the exact same thing. So what we're going to practice is calculating slope, and we're calculating what kind of line it is. Okay, so again, what's the slope of this line right here? What's the slope of all these lines right here that I'm moving around? All 0. That's a big picture. This is that a line starts at +4, and as you move from left to right, it stays at +4. If it started at 4 and it stayed at 4, it hasn't gone anywhere. It's constant. It hasn't changed. The slope or the change is 0. So knowing that, yeah, flat line just going on the flat ground is 0. Okay. That's a big picture thing. You guys might remember Slope Dude. Might remember. Let's see which one it is here. Slope Dude. Yeah. Pretty bad. It's actually really bad. Oh, we gotta play it. It's just volume going here.
Yeah, there's no like advertising or anything.
Yeah, I took off all the advertising.
Oh.
I just wished it and it happened.
Well, you should have wished for something better.
He wants to play though.
They're not eating it.
Same thing on here. Pick 2 points, lattice points, which means the line we're looking at goes right across, an intersection like this. On here, it's already picked for you. There's several points. We're going to find the slope several times. All right. Here's a big idea, though. If we pick, let's say, these 2 points and calculate it, what's the slope here? From here to here, how many? How many is it? 5? Is it going up or down? Okay. From here to here. Down. So anytime we say we count down, we're going from this point, the left point, to the right point. So we have to count down. It's negative. Right here. How many points is this? Or how many squares is this? 2. But we went to the right, so it's positive. So down is left.
Isn't that 4?
I don't know. So this is 5. Is it 5 or 4? Okay, so negative 4 then. So we have slope is negative 4 over positive 2. What if we counted some other points? What if I counted about these right here? From here to here, and from here to here. So from here to here is positive 1 because we went to the right, and from here to here is negative 2. So the slope is negative 2 over 1. Are these equal to each other? Yes. So the big idea for all this is that no matter what 2 points you pick, you have to get the same slope. If you pick these 2 points and you got negative 4 over 2, and somebody else picked these 2 points, it shouldn't matter. You're not going to get a different slope. It's just that exact same slope. Exact same slope. Alright, doesn't matter where we count from. Alright, so here we have to figure out what are the points we're going to use, the lattice points. So where does it go through exactly like one of these? You can see like right here and where else? Not here, not here, or the bottom. So we only need 2, but you have to pick these points correctly. So we can go from here to here, and then from here to here. All right. What do we have here? How much from here to here? Positive or negative? Yeah, positive since we're going up, and positive since we're going right. So we have m equals, what is it? 3 over 1. We also could have picked from here and then all the way up to here. Could have picked that. We would have said, oh, that's positive 2 and this is positive 6. So this would equal 6 over 2. Are these equal? Yeah, so you know you did it right. So you can always check with other points if you have them to see if you got the same answer. So one line has one slope only. Doesn't matter which 2 points you pick. What if I counted the other direction? What would happen then? What if I counted from here to here? What would that be? If I counted from this point to this point, it'd be negative 6. And if I counted from this point to this point, it would be negative 2. But what does that equal? Negative 6 over negative 2 equals? Yeah, the negatives cancel out, and you get the same thing. So it really doesn't matter what 2 points I pick, and even what direction I go. One line has one slope. Period. One line has one slope. Okay. Think about a car just driving the same speed, like on the 15 freeway on the way to Vegas, and it's just going the same speed. It doesn't matter what 2 points you pick, or where you measure it from, it's going the same speed. You have to get the same answer. Okay. All right. Is this positive or negative?
Negative.
Yeah, so we already know before we even start, going back to here, that, yeah, nice negative is going down. So if you see it going down, it starts at one point, like on the y-axis, and then it goes down, we know that's negative. It has a negative 1 slope, or it can have a negative 5 slope, or it could be a fraction, negative 5 over 2. Okay. So we can tell before we even start that, okay, this is negative. So when we're doing the work, we know for a fact our answer should be negative. All right, good. Here, what about this? What's this slope?
Okay, positive 1.
Let's look again. What's the slope? Yeah, 0. 0. So again, where is this starting? What is this point right here? 1. And where is it right here? Is that 1? Where is it at right here? 1. Yeah, it's not moving. It stays at 1. It's constant. So not moving is right? Zero slope. It's not going up, it's not going down. It just stays constant. It doesn't go anywhere. Very important. Know that this is zero. It starts at 1, stays at 1, no matter which direction. It doesn't move. Right? Is this positive or negative? Positive or negative? Is it going up? Yeah. How much up? How many?
1.
And to the right, how many? 2. What's the slope? What is it? 2 over 1. Is that right? Or is it 1 over 2? Which one is it? All right. Yeah. We always want to put the rise first. So it's going to be 1 over 2 on this one. And on here, here's where we have to go up to, and then we have to go right 1. So here's where we get a slope of positive 2 over positive 1. So look at the difference between 2 over 1 and 1 over 2. It's a very different line. So we can't confuse what number goes on top. It's always the rise on top. We're always concerned about, are we moving first? Are we going up or down? That's always more important. Are we going up and down, and how much? So we want to know, are we a constant function, not really not moving, or are we going up? Slope of 1, slope of 2, slope of 3, or are we going down? All right. So that's all we really need to talk about. Here, if we picked a point, any 2 points, what is this rise here? How far is it from here to here? 1, 2, 3. But what is the run? How far left and right do you have to go? Yeah, we don't go left and right at all, right? So that's why we get 3 over 0. But remember, if you get 0, that's where the undefined comes from. Okay, so always think of, if you get, always think of no, n over 0. So if you get a 0 on the bottom, think no. That's undefined. That's undefined. If you get a 0 on the top, that's okay. The answer is just 0. So no with a 0 on the bottom, okay with a 0 on top, it just equals 0. So this is undefined. All right. So I'm going to have you guys practice a little bit. Pass this out, then get started. Up here. Now, the first thing we want to do when we start this is I want you to tell me what the sign of the slope is. What's the sign? So is this a positive or a negative? Positive or negative? So you're thinking this. Okay, so if this is positive, and we're going nice, negative, downhill. Positive, nice, negative. So is this positive or negative? Negative. Right. So put n equals and just put a negative, please. Go to number 2, same thing. N equals, what is this? Positive or negative? Positive. N equals positive. Go down to number 3. What about number 3? What do you think?
Positive.
All right. Good.
Number 4 is negative.
Number 4, what do you think?
Negative. Negatory.
Negative. All right. So far, that's what you have on your page. This one. I want you to get used to looking at the sign of your answer before anything else. Before you do anything else, you're observing if this was an actual vehicle or a car or something flying through space, it says positive or negative. Okay. Let's finish it all up. 5 is positive. 6 is negative. 7 is positive. 8 is 8 is 0. It's not going up from here. It's not going up. It's not going down. It just stays the same. So slope is the change. It's not changing at all. So there is zero slope. There is zero slope. Number 9?
Undefined.
Yeah, that's, you
Undefined.
see when you go straight up and down, that's when you get undefined. So you're right. M equals UNDEFINED. Write out the word, the full word, spell it correctly, please. And of course, number 10, the last one is,
Negative.
yeah, that one's negative. It's going down. Going down. So we know the sign before anything else. Okay. Going back to the top here. Here's where we can start calculating slope. That's not right. There we go. We can start calculating slope. If you need to, you can draw these so you can count easier. If you don't need them, that's fine as well. But you can draw these like a triangle. Sometimes it helps. All right, so from here to here, how many do we have to go? Negative 3. Because we went down. And from here to here, positive 3. So our answer is negative 3 over 3, which equals negative 1. Which means negative 1 is the same as negative 1 over 1, which means the smallest step we can take on this line is really, we could have gone down 1, right 1. We could have gone down and then right 1. We didn't really have to go down 3, right 3. So when it reduces, that tells us what the smallest step we could take is. All right, what about number 2? What's the rise? And what's the run?
5. 5.
So we have to go up 1, 2, 3, 4, 5. So yeah, up 5, and the run is, yeah, we went.
It's a 6.
Yeah, that's 5. Okay. So we get a slope, and do write it like this: m equals. Every time you write a slope, you should have the m equals in front. Those are those little things that you lose points for. So you just put a random number. It's like, okay, you put 5 over 2. Well, what is that? We don't know. We don't know until you put m equals in front of it if it's the slope or not. So always put the slope. Okay. And if you're graphing, you kind of want it as 5 over 1. If you want to know the run is 1. If we're not graphing, just ask for the slope. We can reduce it to 5. What's the rise here? Number 3? Positive or negative? Positive. We counted up. What's the run? Positive, because we counted to the right. So our slope is m equals 3 over 2. Good. Let's skip down to number 8. I want you to show me that the slope is 0. So I'm just going to pick another point. What's the rise from this point to this point? Up and down. How much?
0.
0. What's the run? How far from this point to this point? 4. And what does 0 over 4 equal? 0. Remember, it's okay. Right? It's okay when you have a 0 on top. So that's why the answer is 0. We do have a run. It's just at the right. It's not going up or down. So that's why we're not moving. Same thing on number 9. Prove to me that the answer is undefined. Pick 2 points. Pick any 2 points. On this one, what's the rise? I got 5. Yours might be different, but the rise on here is 5. What's the run on this one? The run is 0. And remember, when you have a 0 on the bottom, think of this. No. You cannot have a 0 on the bottom, and that's why we get an answer of undefined. It's because the run equals 0. Every time the run is equal to 0, the left and right movement, that's when we get undefined. Good. Finish up the front. Finish up the front there. First thing, let's talk about the format before we get to anywhere else. Kind of like on the front where everything has to be, when you say slope, you have to do n equals. Same thing on the back, by the way. On here, you're going to find the slope. You need n equals in front of all your slopes. But also, in addition, we're going to plot the points. So here's 1, 1. It's just like the warm-up we did today. 3, 4. Plot 2 points. 1, 2, 3, 4. Oh, 1, 2, 3. Now, I need you to use your straight edge, that ruler I gave you. And draw a line through the entire graph using. We're going to draw a line all the way through. Put arrows at both ends. So for each of these, it's going to have some criteria. One, of course, straight. Straight line. So that means you have to use a straight edge. Now you don't have to use necessarily a ruler. We're not actually measuring anything, right? So you could use your student ID card. You could use the side of a book. You could use, fold a piece of paper a couple times. Anything will work. Second, don't forget the arrows. Okay. And third, all your answers should be n equals. So I'll be checking all those when I look at this. And as well as every graph you ever do. If it's a linear graph, if it's a line, it needs to be straight using a straight edge. It should go through the entire graph. And if you're calculating slope, make sure you start off with n equals. So we can finish up this one. Oh, if you want to be very accurate, which I wouldn't mind if you did, you can see the slope here is going to be +3 over +2. So we'd say slope is equal to 3 over 2. It doesn't reduce. Okay? And then to be accurate, continue it on your line. Go up 3, 1, 2, 3, over 2. It should be on the line that you already drawn. Up 3, over 2. You can also go back down to where you started, and you can go down 3, 1, 2, 3, and left 2. That should be on the line as well. Down 1, 2, 3, and left 2. If it doesn't, it means you drew your line a little crooked. So be as precise and exact as possible. 1, 2, 3, over 2. Be exact and precise as possible. Okay, if you want to wait to draw your line until you calculate the slope and then make these other dots, and then draw your line, that'd be good. The more dots you plot, the more accurate it will be. So practice on this other one. So it's number 12. So let's plot 0, 0. Let's plot 5, 4. Alright, so what is the slope here?
4.
Yeah, we have to go up 4 and right 5, so that's 4 over 5. So before we do the line though, let's continue this. Let's go up 4 again. 1, 2, 3, 4. And to the right 5. 1, 2, 3, 4, 5. It should be on a nice straight line. We can also go here, we can go down 4. 1, 2, 3, 4. And left 5. 1, 2, 3, 4, and 5. Why can we go down and left? Because that's the same as negative 4 over negative 5, which equals positive 1/5. That's why we're able to go down and left. And again, you can see how they line up on a perfect straight line. So then when you have multiple dots, the more dots the better, that's when you want to go through straight line using a straight edge, going through all the dots, and arrows on either end. Because this line actually keeps on going. If we could zoom out, it would keep on going. Kind of like over here that I can look at a line on this right here, but I can also zoom out. You know, count by thousands. You can see the line keeps on going. It doesn't stop just at 10. It does keep on going on forever. So that's why we put the arrows at the end. Because if we zoomed out, it would keep on going. It's kind of like if you're looking at Google Maps. As soon as you zoom out, you see that there's more around you. It's not just what you're looking at right in front of you. There's all this other stuff around what you're looking at as well. So very precise. The skill of actually counting squares, okay, if that's what we're doing, but I'm checking so much more than that. I'm checking, you know, are you using straight edge? And you must do this on every homework. Every time you do a graph, it must be a straight edge. If there's one that's not with a ruler, I'll hand it back to you. Okay? You must use a straight edge. You must draw arrows. And you must put m equals. If you're calculating slope, you must have m equals in front of it. So we know, oh, that's the slope. All right. Work on that for a few minutes. Tomorrow we'll warm up on another game. The boat.
In the garden. The garden?